Okay, so in the previous video O30, we understood the condition for the first minima in our diffraction setup. Let us here get a grip on the position of the first minima from the center point O. So let us take a slit EI with rays from the slit edges E and I interfering at P. Now remember that this diagram is not to scale and D is much larger than the slit width and wavelength. And a better picture of reality will be something like this, where ray EP and IP will be nearly parallel. So coming back to our unscaled version, we can take rays EP and IP to be nearly parallel. Now let C be the middle point of the slit and let us draw the ray from C to P. Also let us draw a line ED perpendicular to IP, and since P is the first minima point, the path difference between the ray EP and IP is equal to lambda, as we learned in video O30. So length ID is equal to lambda. So if angle PCO is theta, then by the geometry of parallel lines, angle IED will also be theta. Now in triangle IDE, angle D is 90 degrees and sine theta then is equal to lambda by A. Now since D is much larger than A and lambda, theta will be a small angle and therefore sine theta will be nearly equal to theta. That is, theta here is equal to lambda by A, which implies that the angular position of point P from line CO is equal to lambda by A. Now for the separation of point P from O, for small angle theta, we can write theta is nearly equal to OP by D using the formula theta is equal to arc by radius, which implies that length OP is equal to lambda D by A. So the first minima at P is at a distance of lambda D by A from the center point O, and that is the answer to our question.